Hello everyone, welcome to the live class. So guys, today we are having another very important session in which we are going to discuss some more frequently asked questions and the concepts based on them. So I hope today's session will even be helpful for all of you guys. Also, before starting the discussion about all these concepts and the questions which we will consider in this session, please let me know once in the comments that is everything all right, audio, video, slides, everything fine. If yes, then we will start the discussion about the concepts and the points and everything which we are going to discuss in this session quickly. So please let me know once in the comments. And guys, one more thing, that this session will be helpful for all of you, okay, those who are going to prepare for the upcoming CSIR net exam. So I hope that all the sessions which I have conducted before this one, you all have watched them, and if not, you can check them out. Also, the special classes I have conducted, okay, for them, the link is given in the description of this video. You can click on that link and you can check out the special classes I have conducted, okay. You will be able to watch them now even if you have not watched them till now. Also on Unacademy learning app, you can search Anjali Arora. You will get my profile there. You can even follow me there to know about more special classes which I will conduct and more important concepts and the sessions which I am going to consider in these sessions. Okay, so is everything all right? Audio, video, slides, everything fine? If yes, that's good. I'm just going to check your comments along with this discussion. Very good morning, everyone. Guys, I think the things you need to fill in that, like the admit card, there is a form attached with that. Okay, so I think the form, if it is already there, they have mentioned it there that you can consider it before or fill all the details before. Okay, so still you can do one more thing. If you are not sure about it, even after reading the instructions, you can arrange something with you so that if they will ask you to just apply it in front of them or earlier itself, so you will be able to manage it at that point of time. You can consider it in this way. I just checked your comments. Done? Or I will even just check it once again and will try to let you know in tomorrow's session if it is not getting clear to you. Done? All physics concepts, it's good to wait for the official information or the notification regarding that, okay, because then only we can finalize that on which date or which month we are going to have our next exam. Okay, until and unless we are having any official information about it, we can just get an approximate idea. We can't say something exactly. Okay, so let's wait for the official notification. Okay guys, so I hope everything is clear. Let's continue the discussion. In the starting, I'm just going to take some time to let you know about some of the important points, and after that we will consider the discussion about the most important concepts. And if you are watching this session till now and you are going to watch it after this point of time, you are going to get so many important points from the condensed matter physics in today's session. Also guys, these are the points from where the questions have been asked so frequently, repeatedly, okay, and with this session, the information which you will get will help you to solve those type of questions just in few seconds. Okay, so yeah, let me just provide you some information first and then we are going to start the discussion. So guys, if I am going to talk about the Unacademy Plus subscription, as you all know about it, there are going to be so many important courses going on by all the top educators for your upcoming exam preparation right now. Like you are having your exam just in some time, in just few remaining days. Okay, so guys, in that case, still right now the quick revision sessions, the practice course and many important courses are going on Unacademy Plus. But after this exam, we are going to have the sessions for the GATE physics exam preparation and for your next CSIR net exam. Okay, because guys, after this exam, exactly those who are going to think or those who want to prepare for the next exam, they should start their preparation. They should not wait for this thing that, oh, when the exam date will be will get released, or when we will get to know about it, in which month we will have the exam, then only we will start the preparation. No, you don't need to wait for that. You can start preparing after this exam exactly for the next exam. Okay, those things you will get to know soon, because the exam will be there, when, in which month, and everything you will get to know about them. Okay, so you should not wait for that information to get released first to start your preparation. You should start it exactly after this exam, or even if you have started it already for the next exam, that's very good, guys. Now the point is, for GATE physics exam preparation, for next CSIR net exam preparation, if you want to prepare with the guidance of all the top educators we are having on Unacademy Plus for your upcoming exam preparations, then you can take the Unacademy Plus subscription. Because after taking the Unacademy Plus subscription, you are going to get so many benefits. Okay, and like main thing, guidance by all the top educators, mock test analysis sessions, well structured and well planned courses for your exam preparation, and everything. All these things together will help you a lot to prepare for your upcoming exams. Also guys, by using and by applying this referral code, that is Anjali Arora, as it is mentioned here, no space in between, spelling should be same, that's how you need to write it and apply it, to get the 10% discount in the total Unacademy Plus subscription amount. Even if you are going to take the subscription today, tomorrow, day after tomorrow, or after few days, anytime you can use and apply the referral code Anjali Arora, and you can get the 10% discount in the total Unacademy Plus subscription amount. Okay, and the Unacademy Plus courses will help you a lot to prepare very well for your upcoming exam. Clear? And whether for GATE physics exam or CSIR net physics exam, for both the exams it will be helpful for you. Also guys, if you want, you can use this referral code, that is AnjaliALive. Both will work, Anjali Arora or AnjaliALive. Okay, at a time you can use any one of the referral codes, so anyone you can use. Okay, Anjali Arora or AnjaliALive. Another thing is that we are also going to have the championship mock test going on Unacademy Plus. Every Sunday till now before your exam, we are going to have the championship mock test, and then in the same week, in upcoming days, we are going to have the championship mock test analysis session as well. So all of you can participate in this too. It will be helpful for you and will help you to know about the let's say to manage your time, how to attempt the online exam, and many important things will get clear to you with these mock tests. They are gonna be very important. Okay, one more thing, Revise India series is going on Unacademy Plus. If you have not attended the sessions in this series which I have conducted, you can check the description of this video. There will be a link to check the special classes and the free live classes. You can click on that. You will get to know about the sessions I have conducted. If you have missed them and you are getting to know about it for the first time today, you can check it from the link given in the description, and you can check out those sessions too. Okay, these sessions will even be helpful for all of you. So guys, I hope now each and everything will be clear to all of you, and we can start the discussion. Okay, and Sirsa, when you will download your admit card online, you will have the something related to like COVID situation, and some of the data or the information about you will be required there. In the admit card itself, there will be a form. Okay, so you will check it out, you will get it there. Clear? So check your admit card, it will be there, and every point is mentioned there. So guys, if anybody is here right now who has not read all the instructions given in the admit card, please check it out. It will be helpful for you and get to know about every important point. Now let me know, are you all ready for the discussion, and can I start the discussion? And as I have told you, it's going to be very important session today for the condensed matter physics. Basically, if we are talking about the condensed matter physics, guys, there are going to be so many important topics. Okay, like if I'm talking about the crystal structure, in that topic itself, there are many subtopics. Then lattice vibrations, again many subtopics, sub-concepts which are important. Then we talk about superconductors. Then we are having, let's say, mainly 4-5 formulae in that particular topic, but the data or the information is more. Still, if we talk about the theories, there are going to be classical theory, Einstein's theory, debate theory. Then if we are talking about the next point, that's going to be related to Fermi energy, okay, Fermi velocity, Fermi wave vector, okay, the radius of the Fermi sphere. So these are some of the points which are very, very, very important. And what you need to do, most of the times students are not confident about condensed matter physics. Why? Because they are not familiar exactly with the points which they need to prepare for the exam. So I hope this session will make most of your doubts clear and will make you ready for solving most of the questions from the condensed matter physics in the exam. So ready for the discussion? Okay, Sirsa, it is also there in the form. Please check it out. You will get that point there too. Clear? Now, guys, here is your first question, and after that, I'm going to provide you so much important information. That's very, very, very important one. Okay, so first question and then some information. Okay, which will help you to solve this one and many other questions too. Here it is, guys. The low energy electronic excitations If something will not be clear to you anywhere, you can tell me about it in the comments. I will keep on checking your comments in between. In a two-dimensional sheet of graphene, it's sheet is given by E is equal to h cut nu k, where here basically you can call it V instead of nu. It's more better because here they have taken this symbol for velocity, where V is the velocity of the excitations the density of states, and it is a question from the previous year's CSIR net physics exam. The density of states is proportional to, and there are many such type of questions based on the density of states they have asked so frequently and many times in the previous year. So it's very important concept. E to the power 3 by 2, e to the power 1 by 2, E square. If you find it a difficult question, a difficult concept, after discussion you are going to find it very easy one. Just a second, let me just make it more clear to you. I think now it will be completely readable and everything will be clear too. So let me know once you will get it done. You can just mention it in the comments, and if you are someone who is not familiar with it, like okay, how I will solve, what are the points I need to consider or anything, you can just mention it in the comments. I am going to provide you all the information you need to solve any such type of question. Okay, all the information. That means after that you will be ready, like oh, any such type of question based on density of states, I can solve it. Done? Very good Renu, very good Nandita, very good Vishmaya, very good Gagan, very good Kaku, very good Omkar, very good Mitali, very good all physics concepts, very good Saddam. What about others, guys? Whatever answer is correct according to you, you can mention it. If you don't know about it, don't worry, then we will discuss. Very good Shraddha, very good Gauri. Very good, Aradhna. Very good, Polarao. That's very good, everyone. So basically, what you need to do in this case and how you are going to get the right answer. So basically, what you can do in this case or any such type of case or situation, you can prepare it, okay, that what they are asking you to find and what is the dependency directly, okay. I will even give you some more similar type of question so that you will be able to get it more clearly, like what exactly are the steps you need to take and how you can get the answer. Very good, Subramanyam. Very good, Akhtar. That's very good, Shraddha. Very good, everyone. Okay, that's gonna be d upon s minus 1. Very good, Akhtar. That's how you can exactly get it and easily you can find it out. Clear? So guys, basically in any such case, if you want to know about the density of states, okay, what you need to do, you can write the formula. That is a trick. So you can directly mention it in this way. What is the dependency of E on K? That is K to the power 1. Okay, so here the power is 1. Clear? So what you can do, you can directly write the dependency of density of states on d upon s minus 1. What is d here? Dimensions. How many dimensions? 2. Okay, 2D cases there. So it will be e to the power 2 upon 1 minus 1. That's how you can get the dependency and how you need to and where you need to consider it whenever they have given you the energy dependency on K and they have given you any such expression, then you can use this formula and get your answer. Okay, so e to the power 2 minus 1, that will be what? It's gonna be just e to the power 1 and that's how you can find it out. Okay. Is this clear, Ravinder? And to everyone, is it clear now? I will even take more such type of questions to make the concept more clear to you. And there are going to be some combined tricks, combined points, okay, which will make the time which you are going to devote to solve a question less. Now you will be able to get the answer just in few seconds. So anytime if you know about the dependency of energy on K, then what you need to do, you can use this formula and get the answer. Is this clear to everyone? Done? Sirsa, look at the power of K. Look at the power of K. Done? How? Very good, physics paradox. Meenu, is that clear? That is the power of K. Look at this. K to the power 1. So E is proportional to K to the power S. In that case, the density of states will be proportional to e to the power d upon s minus 1. That's how you can write it. Okay. So now I'm going to talk about the next concept. And again, throughout the session, every concept is going to be very important and every point is going to be quite important. So guys, have a look at the next question now. Still, if there will be any doubt, anybody will have at any point, you can just mention it. Okay. Jyoti, is that clear now? S is the power of K you had. And let me just give you more such type of questions to make it more clear to you. And as you know, density of states concept, the questions, they are frequently asked, very frequently asked. Clear? And this is mainly for the case when they have given you the relation between E and K. Okay, then you will use it. Here is your next question, guys. Look at this. All these are from the previous years. The questions I am giving you right now. The pressure of a non-relativistic free Fermi gas in 3 dimensions 3D depends at t is equal to 0 on the density of fermions. This is a different question, okay, but again you will get some very important data from here. On the density of fermions n as options are n to the power 5 by 3, n to the power 1 by 3, n to the power 2 by 3 and n to the power 4 by 3. Clear? Try it now, and if you don't know about it, don't worry, I will discuss. I will start the discussion just in some time. Clear? And keep on noting down the points, whatever is new for you and you are getting for the first time, like if any point is there, just note it down, okay, along with like in your formula notebook, along with all other formulae you have prepared, so that when you will revise, it will be clear and you will have a good command on it after revising it so many times. That's very good, everyone. Just going to check your comments right now. Very good, Subrahmanyam. Very good, Prabir. Very good, Ashutosh. Very good, Karishma. Very good, Kaku. Very good, Polaro. Very good, Monish. Very good, Saddam. Very good, Gagan. Very good, Ishan. Very good, Prerna. Very good, Monish. Very good, Renu. Deepika. Mohammed Manish. Okay, yeah, it's done. Very good, Nivedita. Very good, Aradhna. Very good, Mitali. Very good, Bubbly. Very good, Saddam. Very good, Vismaya. Very good, Physics Paradox. That's very good, everyone. So guys, basically in this case, what you are going to do, it's gonna be S upon D plus 1. Okay, the trick if you are just going to apply. And for the non-relativistic case, S will be what? 2. Clear? So for any such case, non-relativistic case, if you want to know about the dependency on N, okay, it's gonna depend on N to the power S upon D plus 1. And now S is what? For non-relativistic case, note down the value of S, that's gonna be 2. Clear? For non-relativistic case, S will be what? 2. And what is the dimension here? That's gonna be 3D case. Okay, 3D case. It's already mentioned at this point. So D is equal to 3. So what will happen now? When you are just going to put the value, you are going to get N to the power, okay, 2 by 3 plus 1, which means 5 by 3. Okay, and which is present in option A. So that's how you can find this dependency, and it's gonna be the important one. And I know those who are considering the power 1 by 3, okay, or those who are considering 2 by 3, they are considering the standard formula, but it is for the non-relativistic case, due to which you are going to have a difference in the answer. No, Ravinder, S is not a spin here, it is just the dependency. Like we have observed the energy and K relation in the previous question, and we have considered the same relation there. So depending on that, you are even going to consider it, but it is fixed. For non-relativistic case, write it 2, or it will be the value you can memorize, okay, and then in this trick you can put it directly. Is that clear to every one of you? Okay, and if you were making mistake in this particular question or concept, please focus on the related points and the trick part, okay, it will be clear to you. Gagan, then we are having the standard formula for 1D, 2D and 3D cases, okay, and we are going to talk about them as well. Done. And when you consider the relativistic case, just either you can make only change in this formula, the value of S, you will take it as equal to 1. Okay, so it will be 1 upon dimensions. If it is 1D, 2D or 3D case, you can note it down, D1 for the 1D case, D2 for 2D case, and D3 for the 3D case. Done. Can we talk about the next question? Is that clear to all of you? Shivam, okay, let me just explain this once again. If you are having a non-relativistic case anytime given to you and you want to find the dependency of pressure on the density of fermions, which means N, okay, what you have to do in this case, you can directly use the formula written here. That is, the dependency of pressure on the density of fermions will be dependent in the way that is n to the power s upon d plus 1. Where if the case is non-relativistic case, you will put the value of s is equal to 2. Okay, memorize it. If possible, it will help you to solve the questions in very less time. And D is the dimension. Like here they have mentioned 3D case, so D will be 3. If they will mention 2D case, D will be 2. If they will mention 1D case, D will be 1, but S will remain 2. If they are going to ask you for the relativistic case, you will put S is equal to 1. Okay, and depending on the dimensions, just make the changes in D value. That is, for 1D, D is equal to 1, 2D, D is equal to 2, and 3D, D is equal to 3. I hope it will be clear now. And if you are getting to know about any of these points for the first time, guys, what you need to do, in your formula notebook, note down these expressions, note down the values, and just revise them. Okay, I hope it will be clear to everyone now. Done? Clear? Shankar, for the different cases we are going to talk about it. So right now, Fermi related like discussion we are doing. I am going to give you more questions based on more concepts. So more points will get clear to you. But this one clear to everyone right now. Here is your next question, guys. Look at this. Again, it is from the previous years. Okay. Yes, Ishan. S is equal to 2 for non-relativistic case. S is equal to 1 for the relativistic case. Here is your next question. Again, guys, that's going to be from the previous years and you may find it similar to the previous question you have already solved. But it is again a previous year question. So I'm going to give it to you to show you like how frequently such type of questions have been asked and they have been repeated. And I hope this time every one of you will be able to get the answer for this question. If the energy dispersion relation, energy dispersion of a 2D electron system, just a second. If the, and see how well it's gonna match with your first question we have considered. Energy dispersion of a two-dimensional electron system is E is equal to U h squared k, where U is this is electron, where U is the velocity and k is momentum, or all are the previous year questions which I'm giving you right now, like even I have given you before this one. Then the density of states excuse me, density of states dE depends on energy as, okay, and the options are 1 upon root E, option B is root E, option C is E, and D is constant. Related with the first question, and I hope you are going to get the answer soon. Excuse me. Please let me know once you will get it done. Very good, Omain. Very good, Akhtar. Very good, Amal. Very good, Gagan. Very good, Deepika. Very good, Prerna. Very good, Datta. Very good, Nikita. Very good, Pularao. Very good, Vismaya. Very good, Renu, Meenu, Aditi, Akhtar. All physics concepts. And Nivedita. Very good, everyone. So I hope now everybody knows it and you are going to have a clear idea about this thing, that how you will find the dependency. And this is again a previous year question. So you can see the similarity in the first one and this one. Just little bit change in the statement and rest is same. Very good, Subramanyam. Very good, Ajay. Very good, Kartikeyan. Very good, Neha, Sirsa, Manas, Shubham, Gauri, Nazia, Saddam, Abhijit, and everyone. That's good. That's good. That's good. Very good, Aditi. Yeah. Very good, Rashmi. Okay. Very good, Aradhna. Clear? So see how it's gonna be easy now. Clear? You can just get the answer just within few seconds. Here is your next question, guys. You can solve this one too. And I will tell you about the concepts involved in this particular question as well. Again, since some formulae will be required, if you don't know about them, I will provide you those formulae too. Clear? Here is your next question. The radius of the Fermi sphere of free electrons please let me know, is it fine now and okay? Okay, that's good. Let's continue the discussion then. So basically, this is your question. Try it and let me know if you know the right answer, if you know the process, and if you don't know about it, I will discuss. Okay, so you can start solving it and let me know as you will get it done. That which option is correct according to you. That's good. Very good, Aradhna. Very good, Gagan. What about others? Just two answers. Says you are going to get the answer. You can mention it, like which option is correct according to you, and it has been removed from here. Let me just write it once again. The power was In option C, it's 1 upon 3, pi square upon a cube 1 upon 3, and option D is 1 upon 3. Okay, that's what you are going to have. Very good Nazia, very good Salman, very good Subramanyam, very good Ravinder, very good Manas, very good everyone, very good Datta. What about others? Anybody is there who want me to discuss it and is not clear to someone and don't know about the steps, don't know about the concept, don't know about what are the like formulae related to this particular concept which you need to use to get the answer for any such type of question. If you don't know about that, please let me know. I am going to provide you all that information then, and we are going to talk about it. So those who are getting option A, their answer is gonna be the correct answer. But if you know about it, okay, basically if you don't, I will provide you the information. Now, if I'm going to talk about the formulae, guys, which you need to use and which you need to know to solve any such type of question, okay, let's talk about that thing first. So there are going to be different formulae. Here, what you need to find? You need to find the radius of the Fermi sphere. Okay, so basically, first of all, note down all the expressions I am going to provide you right now. And I hope to solve any such type of question, this information is going to help you a lot and so much. So what is that? Let's talk about it. Look at this. These formulae are very important ones. Here is the Fermi wave vector, which we denote or we show with Kf. So for 1D, for 2D and for 3D, we are going to mention it. One dimension, 1D, 2D and 3D case. Here, that's what I'm going to tell you right now. So it's going to be for 1D, the Kf value will be n pi upon 2L, because it is 1D case, so only length L you are writing here. For 2D case, it's going to be 2 pi, okay, n upon a to the power 1 upon 2. If they ask you to find the Fermi wave vector, or if they are asking you to find the radius of the Fermi sphere, this is the formula you need to use. And these are most important ones. If you have not prepared these formulae till now, you should do this. Okay, you should prepare them because it's gonna be something very important. Okay, if you were missing these formulae, guys, you were missing something major and very important. It's gonna be 3 pi square n upon V. 3D case means volume, 2D case means area in the denominator, and the power means 1 upon 3, 1 upon 2 and 1 itself. Okay, and 1D case only length. So these are the relation where n is the number density. Like you can even write only small n here and n upon v place. In place of n upon v, you can write a small n that will represent the number. In place of n upon a, you can only write a small n that will represent the number density again per unit area. And n upon L, you can even write it as small n that will again represent the number density. Is everything alright till now? Similarly, I am going to provide you some more information. Okay, some more information about the Fermi energy. Okay, and this is only applicable for fermions, the information which I will provide you. In the other cases, wherever the tricks will be applicable, that we have already considered, when they have given you the dispersion relation, how you will observe the dependency and how you will write it, that we have considered. We will talk about that particular question, but before that, please note down the important formula I am providing you right now. Sometimes you may even get a question based on dependency, which you will be able to answer with this 1D, 2D and 3D expression in relations easily. Okay, you will be answer that. Okay, if I am going to talk about the next point, that is related to Fermi energy. These formulae are only for fermions. They are not applicable. You can't use them for bosons. Okay, it will not give you the right answer if you will use it for bosons. Sirsa, n upon v for 3D case, n upon a area in the denominator, for 2D case, n upon L for the 1D case. If you want to replace n upon a with a small n, which will show the number density, instead of writing n upon a v completely or n upon a completely, if you want, you can even write only small n there, and that will represent the number density. Okay, so yeah, I am going to discuss it with the question Nivedita, so it will get you more clear. Okay, otherwise if they have only provided you number density instead of the number of electrons present, or number of fermions, any such information, if they didn't provide you and they provided you number density, then you will write n upon b is equal to small n, n upon a is equal to small n. That's what you will do. Okay, let's consider the next formula, which is again very important one. So that is going to be related to Fermi energy. If you have not prepared these ones, guys, for 1D, 2D and 3D cases, you need to know about them. Again, it's going to be h squared square, kf square, corresponding dimension kf value you need to write at that place, upon 2n. Okay, again for 2D, same thing, just kf square, h squared square 2m, and just put kf square here. Just put kf square here. Same formula, but corresponding kf, corresponding kf. That's it. That means you are putting only some efforts to memorize the radius of Fermi sphere, or you can say the wave vector, and you are ready with the second formula for the Fermi energy. If I am going to talk about the Fermi velocity, what will be the case now for 1D, 2D and 3D cases? Same thing, everything will remain same, just h squared kf. Corresponding to 1D, 2D and 3D cases, just put the value of kf here, and you are ready for the 1D, 2D and 3D cases BF formula, that is for Fermi velocity. Okay, now these many formulae you got to know with only this much discussion, which are going to be quite important. Another one, again if I am going to talk about the next one, that is for Fermi temperature. So you can write it like this by relating it with kf. So Tf, that's gonna be h squared square upon 2m kb and kf square. That's it. Then this is what you need to do, and this is gonna give you the answer for the Fermi temperature, and you can expect any such topic based question in your exam. Okay, so whether it's going to be Fermi wave vector, Fermi energy, Fermi velocity, Fermi temperature, any such type of question or concept based question you can get in your exam. Is that clear to every one of you? Clear? And still, if there is any doubt, you can tell me about it, and if everything is clear, that's quite good. Very good. Now let's talk about the question we had. Okay, so the question which we are going to have here we just need to find the radius of Fermi sphere. So let me just show you the question once again. I hope you all have noted down the formula along with the discussion we were doing. Okay, now let me just keep it as it is, and let me just show you the question too. Look at this. Here, first of all, what is that important point you need to conclude and you need to get from the given question? Look at this. The radius of the Fermi sphere, free electrons in a monovalent metal with an FCC structure. When they have mentioned FCC structure, FCC, BCC, SC, when we consider them in 3D cases, so what is the dimension? 3D. Okay, because FCC case is there. I hope that basic point is clear to all of you. Clear? Then from here you got to know about the 3D. But still, if anybody is not getting the idea from this particular point, read it further. So in which the volume of the unit cell is AQ. So they are talking about the volume. When we consider the volume term in 1D case, 2D case or 3D case? 3D case. So again we got the idea, it's a 3D case. They didn't mention it directly, but they have given you many hints in the question itself. Okay, now next point. What they are asking you to find the radius of the Fermi sphere. For what? For 3D case. Did they mention any other thing? Yes, FCC structure and the volume is AQ. Okay, that's good. Next point. Look at this. The radius of Fermi sphere or Fermi wave vector, that is 3 pi square n upon v. What are going to be the effective number of atoms in the FCC case? 4. That means n is equal to what? 4. It's quite easy. And volume is what? AQ. That is already given to you. So 4 into 3, 12. Pi square upon v is AQ. Okay. So 4 into 3, 12. 12 pi square upon a cube to the power 1 by 3. Look at this, the options now. 12 pi square upon a cube to the power 1 by 3, which is in option A, and that's the correct one. So only by knowing about the formula you are getting to know about the right answer quickly and in very less time. Okay, it is for fermion, Sadhana. Is this clear to all of you guys? All physics concepts, that was for the Fermi pressure. Okay, I have mentioned the formula for that too. It's here. Look at this. Fermi energy, Fermi velocity, and you know about the relation between the Fermi momentum. Okay, and you can consider that. See, some of the points you got to know if you know about the relation between the other things, the temperature, pressure, energy, velocity, okay, or the radius of the Fermi sphere or the wave vector. Just by putting those values in other formula, you will get to know about it. Is this clear to all of you? Can we talk about the next question then? Nazia, did you prepare the crystal structure topic? Like crystal structure and subtopics? Because then we are going to talk about the different crystal systems in 3D case. Okay, there are going to be basically 7 different crystal systems, and I'm going to tell you a trick to memorize them if anybody is here who has not prepared. Like one question was here in the comments that how we are getting n is equal to 4. Okay, for the FCC case we are getting it because in the question it was mentioned it is FCC case. So guys, there are going to be different crystal systems, how many and how you can memorize them along with their conditions. So let me just tell you. There is a trick, the statement city over. Basically, I'm writing it as C and T, but it is like the city, शहर वाला city. Okay? But you need to write it as city. Over real, home, maintain, free, clean. That's another trick. Then C for cubic, T for tetragonal, O for orthorhombic, R for rhombohedral, H hexagonal, M for monoclinic. Triclinic means triclinic. You got to know about the sequence till now. What is that? Cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, triclinic. Okay, how many? 1, 2, 3, 4, 5, 6, 7. 7. Now, along with that, corresponding to the lattice parameters, that means ABC and lattice parameters, you can say only ABC you can consider, or you can consider, let's say, alpha, beta, gamma, the angles. Okay, into them we are going to have the conditions for each and every case. That is whether you are going to talk about, guys, just a second, I think again it just, is everything all right? Please mention it in the comments once. I'm just going to check it once. Is everything all right now? Is it okay? I think now it will be fine. Here, no? That's good. So basically, guys, in all these cases, what is going to happen? Basically, there are going to be the lattice parameters A, B, C and alpha, beta, gamma. So once you got to know about the sequence, cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic and triclinic, what will happen after this? You are going to write them in sequence in this manner. Cubic, C, T, tetragonal. Okay? CT, over, O for orthorhombic. So you can even mention that one there. O for orthorhombic. Clear? R, rhombohedral. Clear? R for rhombohedral. We will just write them in sequence right now. I'm going to write it there. City over real, rhombohedral. Okay, home, hexagonal, maintain, monoclinic, preclinic, triclinic. Done? You got to know about all these points. Now the sequence. Look at this. First 3 times write it in this way. A is equal to B is equal to C. A, B, C are the lattice parameters, or you can call them lattice constants. From the right hand side, start putting a not equal to sign here, so that you will not have to put extra efforts to memorize these values. Okay. Then here one not equal to you have introduced, again another not equal to you will introduce here. Let's say like this. After repeating it 3 times, first, second, third, what has happened? We have followed a sequence. We kept all of them equal. We considered one not equal to here. Then we considered 2 not equal to like this. Okay. Now again you have to repeat 1, 2, 3 and 3 repetition. Why? Because like the last one will be remaining, total 7. So 1, 2, 3 means 1 this one. Again write it. 3. And then last one not equal. If you are going to get any such question based on any such concept, okay, basically the conditions on lattice parameters, you can write them in this way and you can get to know about the final answer quickly. When we talk about the other conditions which we will have for the alpha, beta, gamma, in this particular sequence, if you will observe it, you will even be able to get that well, okay, and clearly. But after considering all these points, the sequence basically that matters here, and it makes the conditions easy for you to memorize. When we talk about the cubic, you have 3 different Bravais lattices. That is going to be simple cubic, body-centered cubic and the face-centered cubic. Okay, in the cubic case, there are 3 Bravais lattices. It's a very important point. Again, the questions from this part you can expect so many times. So right now I'm going to consider some discussion related to frequently asked questions. Okay, now look at this. Cubic case, 3 Bravais lattices, which are going to be simple cubic, body-centered cubic and face-centered cubic. When we talk about the simple cubic case, in that particular case, the atoms are going to be at the corners only. Simple cubic case, the atoms will be only at the corners. They will be present only at the corners. If I am going to consider it in this manner, that is, okay, just a second. Let's draw it like this only. This is the simple cubic, let's say. So only atoms will be at the corners. Clear? How many corners or vertices? 8. So 1, 2, 3, 4, 5, 6, 7, 8. Clear? This is simple cubic case and only atoms which are present are at the corners or the vertices. Each atom here from the corner will contribute the 1/8 part in this particular lattice. So how many total such type of atoms are there? 8 at the vertices, and 1/8 contribution from each atom, it will give you 1. How many effective number of atoms will be there in the simple cubic case? Only 1. Always remember this. You may even get the question based on it where you have to use, like the FCC case we had in the last question. So we were considering total effective number of atoms 4. How? Because we know about it from this crystal structure part. Second thing, it is 1/8 contribution of each corner atom, and total 8 corner atoms are there. So total contribution or effective number of atoms in the simple cubic case is equal to 1. When we are talking about the another point, that is BCC case. BCC means the body centered cubic, which means at the center of body, like at the body center of this cube. Okay, body center means at exactly the center of the cube. Let's say this is a room, and in this room, this is a cube shape. Okay, it is in the shape of cube. Now at the center of this room, we are going to have 1 atom. Okay, and at the corners, we are having 1 atom. So this center atom is completely within this room. So complete contribution 1. And each corner atom, if you will consider the rooms in the surroundings, this side, upper, in the upper floor, okay. So in that case, that corner atom, the above one or the lower one, whatever you want to consider, okay, because when you are considering the lower one, you will consider or imagine that in the like below this floor, there is like more room, okay, more rooms are there in the surroundings and everywhere. So it's more better to consider the above one because it makes the things more clear. So that one is going to have the contribution 1 upon 8. In the same way, all the corner atoms will have the contribution 1 upon 8. So what is going to happen? The corner ones total 8. And their contribution in the same lattice, it's going to be 1 upon 8. But the center one, which is completely within this cube, that is going to have the contribution 1. So 1 upon 8 into 8 plus 1, that will give you 2. So effective number of atoms in the BCC case is equal to 2. While at the same time, when we are considering the discussion about the FCC part, what will happen in that case? So when you are considering the FCC part, you will have the atoms present at the corners as well as at the centers of the faces. Okay? So like this, center means how you can consider if this is a room and this is one wall of the room, this side, above, like the floor. Okay, this wall, this is even a wall. Clear? Let's say this is even a wall. So if there is one atom, okay, at this wall, the face I am putting here, then in how it will be present exactly. If this is a wall, let's say, so atom will be like half this side and half that side. So let's say you are having a ball in two parts, okay. So half side you will put one side, that means inside the room, and half on the other side. So that means only half ball will be within this room and the half in the other one. Clear? So how many such walls are there or such faces will be there from where we will get the half contribution of the atom? 6. Because in a cube, how many faces will be there? 6. So 6 into half, that's gonna be 3. Plus, all the corners are having one atom. And again, the corner atom's contribution is 1 upon 8. So 8 into 1 upon 8. Clear? What you are going to get from here? Just have a look at this once again. Okay, clear? If you are going to consider one more thing, because it is having the contribution 2, half ball is within the room and it is having 1 upon 8. So now 2 3s are 6 plus 8 1s are 8, that means 4. So in FCC case, you are going to have effective number of atoms is equal to 4. That's how you are going to get it and you need to memorize it. The second type of question you can expect from this particular part, which is from the crystal structure case, guys, that can be related to the nearest neighbors and the nearest neighbor distance. So one case I am going to explain here right now, and also the selection rules based questions you can expect. Okay, so what kind of questions and how they can ask it to you, let's consider. Basically, if we are going to talk about the selection rules, let's consider them first. They are very important. They are related to X-ray diffraction. Okay, when we observe or we are going to check out the diffraction, whether it is possible from a particular plane in the given crystal or not, there we need to know about the selection rules. For the BCC case, for the SC case and for the FCC case, we are having different selection rules for checking whether the diffraction will be there from a particular plane or not. If I am talking about simple cubic, it will be allowed or you will get the diffraction peak for all possible values of HKL. What are HKL here? These are the Miller indices. What are Miller indices? Miller indices are basically the indices of the planes in a crystal. Because you want to know that which crystal somebody is talking about, you are talking about, where you have observed this particular phenomena. So how you will locate it, how you will tell someone, oh, I have just considered at this particular point. Like when you consider 2D, okay, 2 dimensions thing. So you are talking about the coordinates. Even 3D plane, when you consider, you talk about the coordinates of a point. In the same way, when you are observing a crystal, you want to talk about the plane. And how you can let someone know, oh, I have observed this particular phenomenon for this particular plane with the Miller indices. Okay, those same Miller indices we are going to consider here with HKL notations. And what are the selection rules corresponding to them to get the, let's say, to get to know about this thing, that whether you will get the diffraction peak corresponding to the given plane or not. So for simple cubic case, it will be the diffraction peak you will observe or you will get for all possible values of HKL, all possible values of HKL. That means there is not any major restriction, okay, to get the diffraction peak in the simple cubic case. While if I am talking about the BCC part, that is body centered cubic, then there you are going to observe or you will get the diffraction peak for H plus K plus L even. If H, K and L sum, you are getting it even, then you will be able to observe the diffraction peak. And if it is not the case, you will not get the diffraction peak there. FCC, when either all HKL are odd or all even. Just a second, guys. Or all are odd. That means either all will be even, then you will get a diffraction peak, or all will be odd, then you will get a diffraction peak. Otherwise, you are not going to get it. Clear? So that's how for FCC case you will get the diffraction peak. Now one more last point, I'm just going to talk about that, and if it will get like clear to you, it will be easy for you to get any such type of question. Easily you will be able to understand that, you will be able to answer that particular question. So let's consider one more point. Okay, I hope till this point the discussion which I have done, that will be clear to all of you. Okay, done? Clear? Is there any doubt anybody is having till this point? Any doubt? If yes, if something is not clear to you, you can just mention it. If you know everything till now and everything is clear to you, that's good. One more last point, okay, for today's session. And all these are very, very, very important ones. If I'm going to talk about the next point, guys, that's going to be related to the nearest neighbors or number of nearest neighbors, okay? All physics concepts, there we are going to have a different rule. Two conditions you basically need to check. One, you need to divide by 4. I will tell you the exact condition for that too. And the even concept, both will be involved in the HCP case. Clear? See, guys, when we talk about the simple cubic case, once you will understand how to find it, you will be able to get it for any such a structure. Okay, you just need to get the point well, and once you are understanding that, then any case, any condition, you will get the answer. It's simple cubic case, that means atoms are present at the corners. Once the atoms are present at the corners, if somebody is asking you, okay, find the nearest neighbor distance, find the number of nearest neighbors for this particular case, find the second nearest neighbors, find the second nearest neighbor distance, any such type of question. Once you are getting the first concept well, in the same way you just need to check it for any other, BCC, for FCC, any case. So first thing what you need to do, you need to know about the structure. Like I am talking about the simple cubic case. So we all know that the atoms will be present at the vertices or the corners. Done? That's what we have considered. If somebody is asking us to find the number of nearest neighbors, from where, from which point we will start? So basically from any atom you can start finding it. So let's say I am starting with this one. Okay, what will happen? I just need to consider that in how many different ways from this particular point we can reach to the other atoms. So the first way will be from here to here. Let's say the lattice constant or lattice parameter for this lattice is A. And since it is a cubic case, so all the like dimensions, all the sides are gonna be same. So this one is A. The other one, this one is gonna be A again. Clear? What about this one? It's again A. But what about the face diagonal? Face diagonal means on the same wall, on the same face, when you are moving in this way, you are reaching to the other atom, it will be root 2A, because that is the diagonal of a square. Okay, the other way. Then you are moving from one corner to the another corner in the opposite direction. Okay, in the cube overall, not the face only, but in the cube. Then this distance will be root 3A. Now in how many different ways and how many different distances you have observed? A, root 2A, root 3A. Somebody is asking you to find the nearest neighbor distance, which is the smallest value, A. So for the simple cubic case, what is the nearest neighbor distance? A. How many nearest neighbors are there? How to count that? It is not a single lattice you will have in a crystal. Such type of many lattices, and they will be in a like way, the repetition in a periodic manner you will have. So after this, here this side more, this side more, this side more, up side more, okay, this side more, like every side you will have more lattices. So the point is, how many such atoms at a distance A will be connected to this particular corner atom? 1, 2, 3 vertically downward, opposite to this side back side 4, opposite to this side back side 5, opposite to this side back side 6. Done. So how many such atoms at a distance A it will have, or it will be connected to? 6. So number of nearest neighbors 6. That's how you can find it for any such case. You can even have a look at this, whether you have missed any one of them or everything you have included and you have considered. If yes, everything has been considered, then you are just going to get it in this manner easily. Okay, I hope you will be able to understand that and you will get it easily for any such case. For FCC, for BCC, for second nearest neighbors, anything, whatever they will ask you. And such type of questions are even most frequently asked, and they are easy to answer if you know how to find it. Okay, so guys, this was the discussion for today's session, and thank you so much everyone for joining this session. Tomorrow again at 11:30 we will have the session here. That's again going to be a very important session, and before your exam, that's going to be the last one. Clear? So I hope all these sessions are helping you a lot to prepare well for your exam. And guys, as I have told you about the Revise India series in the starting, you can even check the link in the description for that. Okay, and you can watch those sessions if you have missed any one of the sessions. The special classes which I have conducted, they are going to be important. They will help you to know the concepts. They will help you to prepare the questions, like to get to know about the questions, to practice them, and most important things. Okay, also guys, as I have told you about the Unacademy Plus subscription, if you want to attend more regular live classes by all the top educators, we are having on Unacademy Plus for your upcoming exam preparation. Then you can take the Unacademy Plus subscription. Also guys, by using and by applying the referral code, that is Anjali Arora, as it is mentioned here, no space in between, spelling should be same. That's how you need to write it and apply it to get the 10% discount in the total Unacademy Plus subscription amount. There are going to be so many important courses which are to start soon. For GATE Physics exam, even after this exam, many courses are going to start. If you want to attend the sessions for the GATE Physics exam preparation, even you will be able to continue your preparation with this subscription, okay, which you are going to take to prepare for your CSIR Net Physics exam, the upcoming one, and next to that which you will have, even we are going to have the courses for the next exam as well. Okay, so yeah, whenever you are going to take the subscription, you can use and apply the referral code Anjali Arora to get the 10% discount in the total Unacademy Plus subscription amount. Also guys, one more thing, once you are going to take the Unacademy Plus subscription, after that you will be able to attend the live classes by all the top educators we are having on Unacademy Plus for your upcoming exam preparation. So I hope each and everything will be clear to all of you guys, the discussion which we have done in today's session, and it is gonna be helpful for you. Also guys, we are going to have the championship mock test which is going on Unacademy Plus, on Unacademy learning app. You can check it out and even you can attend these championship mock tests. They will help you to get ready for your exam, to get familiar with the exam pattern, to know like well about the online exams and all. So these mock tests will even help you. Also, we are going to have their analysis session in that same week. Once you are going to have the test on Sunday, after that the analysis session is going to be here. So guys, thank you so much everyone for joining the session. Even if you want to take the Unacademy Plus subscription right now, you can take the subscription. It's going to be very important. Okay, can help you a lot to prepare for the exam with the guidance of all the top educators. And whenever you are going to take the subscription, you can use and apply the referral code, that is Anjali Arora, and you can get the 10% discount on the total Unacademy Plus subscription amount. Thank you everyone for joining this session. Thank you.